Welcome back to a new session. My name is Arun. അപ്പോൾ ഇന്ന് നമ്മൾ ഡെഫിനറ്റ് ഇൻ്റഗ്രലിൻ്റെ സബ്സ്റ്റിറ്റ്യൂഷനാണ് നമ്മൾ നോക്കാൻ വേണ്ടി പോകുന്നത്. സോ ഓൾമോസ്റ്റ് ലൈക്ക് സബ്സ്റ്റിറ്റ്യൂഷൻ യു ഹാവ് യൂസ്ഡ് ഇൻ മെനി പ്ലേസസ് ഡിയർ. ലൈക്ക് ഡിഫറൻസിയേഷൻ നമ്മൾ യൂസ് ചെയ്തിട്ടുണ്ട്, സബ്സ്റ്റിറ്റ്യൂഷൻ ഇൻ്റഗ്രലിന് തന്നെ നമ്മൾ സബ്സ്റ്റിറ്റ്യൂഷൻ നമ്മൾ ചെയ്തിട്ടുണ്ട്, അതെല്ലാം പഠിച്ചിട്ടുണ്ട് അല്ലേ. സോ യു നീഡ് ടു ബ്രെയിൻ സ്റ്റോം ദോസ് തിങ്സ് ആൻഡ് ഓൾ. യു നീഡ് ടു ഗെറ്റ് ബാക്ക് ഓൾ ദ ലോജിക് വാട്ട് യു ഹാവ് ഡൺ ഓൺ ദോസ് ക്വസ്റ്റ്യൻസ് ആൻഡ് ഓൾ. ആൻഡ് with that past experience, dear, we will be just sorting out all the questions from exercise 7.10. Fine. So without any introduction, dear, straight on the exercise on the first question then. On the first question, 0 to 1 x by x square plus 1 dx, dear. So when you get a question like this, you need to know where to substitute first of all. Then when you substitute, what is going to be the limit, that you need to know. Okay, that you will get an idea when I start to do it, dear. And I will just show you the other way around also. Okay, fine. Just be very seriously just approach this question here, because it's the first question and you need to be very particular about how to apply the new limits and all. Okay, you need to look forward for those things. So make sure that you just focus a bit on this question so that you understand the concept of what substitution. Okay, let's see. So I'm gonna write the question again. 0 to 1 x by x square plus 1 dx. Okay, so when I have a question like this, I can see that I can put this one as what, as t or any such variable. Like here x square plus 1, if I'm taking it as t, then as you know that when you check over here, you can see that this one, when you differentiate with respect to x, what I will be getting, 2x dx is equal to dt. Fine. So you have x dx you have, but not 2 there. So what you will do, x dx is equal to dt by 2. Fine. These two are what I'm gonna substitute over here. When I substitute, what I will be getting here is this is gonna be 1 by t, and this x dx is what, dt by 2, right? Now the main thing over here is what will be the lower limit and what would be my upper limit. That won't be same anymore. That is the most important thing. Now how to find that limit? That means when you substitute, okay, why? I will tell you the reason, dear. So when you substitute, you also need to check whether the limits are going to be the same or it's going to change. If it's going to change, then changed over here, dear. Okay, now let's see how it is. As you can see, this is lower limit, which is 0, dear. So I need to check when x is equal to, now this is x, right? Yes. So when x is equal to 0, at that time what happens to t? So at that time, what is t? How would you know that? I would know from here. Take this value and put it over here. So 0 plus 1 is 1, so t is gonna be 1, right? Yes. Now when x is equal to 1, the upper limit, then what happens with t? T is gonna give me a value, t 1 over here, 1 plus 1, 2. So now my upper and lower limit would change to 1 here, because 0 it's 1, and on 1 it's 2 now. Fine, I hope you are getting a clear idea, dear. Once you have this one, then you can integrate it. That's done. So how do you do it? Now I'm going to write it again. 1 to 2, 1 by t. This time this 1 by 2 I'm going to take it outside because it's constant, right? Then your dt, dear. Okay, I just wrote dt. Then I'm going to integrate this one. 1 by t is nothing but log t. Yeah. And I'm going to apply the limit. Yes, and this time what I'm getting here is 1 by 2 into the upper limit, which is log 2, minus your log 1. You know, obviously you know what is log 1. Log 1 is 0, right? So what you will be getting here? 1 by 2 log 2 is what my answer. So what is my final answer here? That is half log 2 is my answer here. Fine. Yes. Now that is in fact my answer. That is correct. Okay, keep it over here. Okay, now I'm gonna write the question again. 0 to 1 x by x square plus 1 dx. Now when I get a question like this, for the exam, if I have a question, then what I would see whether my derivative is there in the numerator. If it is so, it's good. If not, I can adjust it by putting a 2 here and dropping a 1 by 2 here, right? Now you have it. So now what I can write? I can write log of what? When you integrate this one, log of the denominator, which is x square plus 1, and you can apply the limit, right? 0 to 1, which in fact gives me, when you apply it, 1 and 1 would give me 2, then minus log of 0 here, 0 plus 1 is 1, so thus this is gonna be 0 again, what I told you. So what is my answer here? It's 2. So you might ask me, sir, why should I need to do all these when I am getting this straightforward? Yes dear, both the answers is correct, but not always this you would get it dear. So sometimes you just need to make some substitutions, then only you will get into something which of simpler form, so that you can just simplify it much easily, okay, or easier. Otherwise it will be gonna be too hard. So when you go ahead with the next questions or the questions after, you would see what is the importance of what? Your substitution. Yes. Now what I want to show you here is, what if at this stage where I have 1 by t dt by 2, where I'm not gonna change the limit. I forgot to change the limit and just put the same as what I have here. Okay, if I would have done like this, I have told you, if you didn't change or if you didn't do this step dear, it's gonna be a big massive mistake. How? Let's see. 1 by 2 again, it will go out and you're gonna integrate it 0 to 1 by t dt, and when you integrate it, you're gonna get log t with your 0 to 1. And don't tell me now that, sir, why can't I take now this value and put it over here? No, x square plus 1, I cannot put it there because you already took the substitution, you already integrated it, then just need to substitute in that value in which you have integrated. That is the thing. Okay, so when you do so, what you will get? Half, then this is first one is gonna be log 1 minus log 0. What is log 0? Log 0 is undefined dear, undefined. You don't have any value, you cannot define that. Okay, you just have log 1 which is 0. Log 0, there is no value, it is undefined. It cannot happen like that. So that is how we can figure out that this limit should need to be changed. Otherwise, if it is like so, one thing, keep it in the head that whenever you go for substitution, you make sure that you go and apply and see. Sometimes you may get the same thing. Sometimes 0, 0, 1, 1, you may get it. But make sure that you just check it and then change it, then integrate it. Then only your answer will be correct. Fine. So I hope you got a clear idea with the first question. Move on to the second one then. On to second question. 0 to pi by 2 root sine phi cos phi whole raised to 5 d phi dear. So this is the question. Now what you are supposed to do is, again, like we know that we want to substitute. Fine. If you know it, now my question would be, what would be taken as t or any other value? You have two options here. You have only two options here. One is your sine phi could be taken as t. If it is so, what you will get if you differentiate? It would be cos phi d phi is equal to dt. Yes, that's a good option. Let's see. Then what is the other one? It will be cos phi is equal to t. So it will give me minus sine phi d phi is equal to dt. Fine. These type of questions, seriously, when I was in the school also, I used to feel it like which one to take. How would you know it? How could we like, how could the others know like, okay, this is the proper one to take and all? Such type of questions I used to get it, seriously. Maybe you will be encountering with the same thing. So over here, as you can see here, this is going to be minus sine phi, dear. Now minus sine phi root and minus. It's going to be complicated. So skip out this. You don't want this. So this would be the best way. Now let's see the question again. 0 to pi by 4, pi by 2. Yeah. This one, it's okay. I'm gonna put it a t here. Fine. Okay. What happened to this one? Where is my cos phi and all? So for that, what the adjustment, what I'm gonna do here is cos raised to 4 phi, then a cos phi d phi. Okay, dear. So can I write it like this? Yes, of course. And this would be what? My dt. Yes. What is this one? T. Then my question is, what will happen to this? Okay. What will happen to our cos phi raised to 4? We need to just do this thing what I'm gonna write here, dear. Okay. Then only you can move forward. And it's not too hard. You know that already you have sine phi as t. You can change it to sine. Yes, I can. What I will do? Can I put it like this? It's not sine here. I will do it as cos first itself. Cos square phi the whole square. Can I write it like this? This one as like this? Yes. Then cos phi itself, this phi, then d phi. Okay. Now what happened to this? 0 to pi by 2 root sine phi, this one, can I write it like this? 1 minus sine square phi the whole square cos phi d phi. Yes, I can. And this is where you will start to substitute these values. Right? Just think over here, dear. And what will be my substitution? And when you substitute, what you will be getting here? Limits. It's gonna change. We will see that. Okay. Now this one is gonna be root t. Yes. Sine phi is t. So this is root t. 1 minus, this is again t square the whole square. What is this whole thing? Is your dt. So this is your dt. Now about what is my limits. Now check again. It's about what? It's about phi here, right? It's, if it is phi is what? 0. Phi is 0. What will be the value of what? Your t. T in the value and how would we know it? We will be substituting phi here. So what will be t? Sine 0 what will be t? Sine 0 is 0, dear. Yes. Now when phi is equal to, you can write like when, okay, when phi is equal to what? Pi by 2. It's when it is 90. What is t? If it is 90, sine 90 is 1. So what is your new limits? This one your lower limit, this is your upper limit. Okay. Yes. And okay, now here I can put it, your lower is 0 and your upper is 1. Yes, you got a new limits there. Yes, congrats. Now start off with the next question, not next step. What I can do here, 0 to 1, this one I need to expand it, or I also need to just write it like 1 by 2, because I need to expand this one and gonna multiply inside. Okay. Now this was a minus b the whole square. So 1 square minus 2a into b, that is this, plus b square, which is t raised to 4, and your dt. Yes, done. Now after this, let's see. Now I'm gonna multiply inside, which is 0 to 1. T inside, it will be t 1 by 2, t raised to 1 by 2, minus 2t square plus 1 by 2, isn't it? Because you're gonna multiply. So you're gonna multiply with this, you're gonna multiply with this and with this. This one is 1 t raised to 1 by 2 with this minus 2 into t raised to the powers you should need to what? Add. Then with this and this you will be getting t. This is 1 by 2 plus 4. So it's gonna be 1 by 2 plus 4, right? Yes. Now dt. And thus I will be getting 0 to 1. I just need to just add it first. Okay, this whole thing, okay, dt. This is gonna be minus 2t. When you add it, it's gonna be 2, 4, 5 by 2 plus this is t raised to, this is gonna be like 8, 9 by 2 dt. Yes, that is equal to 0 to 1. Now why should I need to write like this? I can simply go ahead and integrate it, dear. Okay, just start integrating. Why simply writing the steps? Now when you integrate this one, this is gonna give me t raised to 1 by 2 plus 1 by 1 by 2 plus 1. This one are gonna give me 2 into t raised to 5 by 2 plus 1 by 5 by 2 plus 1. And then here plus t raised to 9 by 2 plus 1 by 9 by 2 plus 1. Yeah. Then gonna apply the limit, which is 0 to 1. Fine. The lower limit, if you put it 0 to all the t, it's gonna be 0, dear. So you don't need to worry much about the lower limit. Only the upper limit you need to multiply. Now if you take up the okay, now let me just add all these and put it proper. This is gonna be t it is 3 by 2. This will be again 3 by 2. Okay, I will write it 3 by 2. Okay, minus 2. This is gonna be 2, 7 by 2. Hence this will be again 7 by 2 plus t is gonna be 2, 11 by 2, 11 by 2, then 0 to 1. Fine. Yes. Now what do you have here? Now you need to apply it and then reciprocal it. When you apply this 1, dear, okay, let me apply and then I will take it off. This whole term 1 raised to infinity is 1. So 1 raised to 2 raised to, I'm gonna apply it. Okay, നമ്മൾ t ന്റെ അവിടെ വന്നിട്ട് 1 അപ്ലൈ ചെയ്യണം കേട്ടോ. അപ്പോൾ t ന്റെ അവിടെ 1 ഇടുമ്പോൾ എന്ത് പറ്റും? t raised to 1 raised to 3 by 2 is 1. So 1 by 3 by 2. Okay, minus 2 by, this is again 1, 7 by 2 plus this is gonna be 1 by 11 by 2. That's it. Minus your lower limit, when you apply, it's all gonna be 0 because it is 0, 0, 0. Hence what I can write here is, this is gonna be reciprocaling it. I will be getting 2 by 3 minus this will be 4 by 7 and hence this will be 2 by 11, dear. Just calculate it, you will get the answer. Okay, let's see. Let's calculate. Okay, now what would be like 33 and 7. 33 and 7 is 21, 23. So your denominator is 231 and your numerator, let's see. Okay, 70. It's very hard here. Like multiplying this one is not hard, but it will take a bit time. You need to multiply it. So this one with this 77 and this one 154. 77 and 154. And this is gonna be like 7, right? So 33 into 4. So 33 into 4 is gonna be 4, right? Yeah, it's gonna be 4. So 12, 13, 132. So minus 132 plus, what do you have here? This is 21 into 2 is 42. Yes. So hence what is the answer here? 154 minus 132. That will be, already I have the denominator, which is 231. Okay, I just still need my numerator. So this one is 2, then this would be 2 again, 22. 22 plus 42, is gonna be 4 and 6, 64. So what is my numerator? 64 here, and that is gonna be my answer for my second question. On to third question. 0 to 1 sine inverse 2x by 1 plus x square dx dear. I don't know how many of you have an idea about 2x by 1 plus x square, this one. Like these formula or these ones we have seen in many places dear. What you're gonna do here is that you're gonna put let x is equal to tan theta, nothing else. It's gonna be pretty easy, because as you know that 2 tan theta by 1 plus tan square theta, what is the value? It is sine 2 theta dear. When you know it, and when you have a sign over here, you don't need to think twice, just put it inside. So what are you gonna do here? 0, is it 0 to 1? Now I'm gonna write the question again, okay? Anyway, I start off with, so I don't want to rub it. So 2x by 1 plus x square dx, and as I have told you what I'm gonna do, I'm gonna take x is equal to tan theta. So I don't know what it's gonna be, but I know one thing, that it's gonna be inside 2 tan theta by 1 plus tan square theta, and I don't know what is dx also. Let me see. I just want to show you this. My intention of doing so is to get a sine 2 theta, so that this thing could be cancelled and I will get what? 2 theta dear. That is the thing. അപ്പോൾ ഒരു ക്വസ്റ്റ്യൻ കണ്ടാൽ നിങ്ങൾക്ക് മനസ്സിലാവണ്ടേ ഇങ്ങനെ വേണം ചെയ്യാൻ, എന്തിനു വേണ്ടി ചെയ്യുന്നതെന്ന് നിങ്ങൾക്ക് അറിയണം. That is what I'm just making you do dear, or I'm just showing it to you so that you just keep these ones in your mind. Now what happens when you differentiate this? It's gonna be dx is equal to, what is tan theta and the sec square theta, and then d theta dear. Yes. Now what? Now I just need to find if x is equal to, when x is equal to what? 0, what is the value of theta? When x is equal to 1, what is the value of theta? That you need to find it. How you find it? From here, x and theta is what I want, right? So I will see theta is equal to, this one is tan inverse x, isn't it? Tan inverse x. Okay, put it on. Now x is equal to 0, so it will be 0. So what is theta? Theta would be 0, because tan inverse 0 is 0. Now tan inverse 1, when you get a 1, for which value of tan you will get a 1? It's 45, it is pi by 4. So these two are the limits what you need to keep. Now what is the lower limit? This is the lower limit and this is the upper limit here. So it will be 0 and pi by 4. Yes. So we got the limit. But something else we missed out. What is it? dx. What is dx? It's sec square theta d theta. Fine. You might think like it's big dear. Let's see what happens to it. It is sec square theta d theta. This will be again sec square theta d theta. Limit would be from 0 to pi by 4. This would again be from 0 to pi by 4. Fine. So that's done. Now what is the next step? You just need to start integrating it. How? Which one? We know eyelet. Which is the first one? Algebra, because theta is algebra. And I would write one step here by taking 2 outside, 0 to pi by 4. Then theta, sec square theta d theta. And from here, now our equation, not integration here, sorry. How to integrate? The first term into integration of the second term minus integration of differentiation of the first one into integration of the second one and all. You guys know it. You have done in the previous questions and all. And not the previous question, the day before. Yeah, you know it. No, you know this U and V method. Okay, I might not told you like U and V, but you know this one, how to do it. So that is gonna be the first term is, okay, 2 is already there. first theta, first term like that. You're gonna integrate the second term, which is sec square theta d theta minus, you're gonna put a big integral sign, and you're gonna differentiate the first. What is the differentiation of theta? Is 1. Then gonna integrate what? Sec square theta d theta, close the bracket, and then the theta with this, right? So what do you have? And also when you integrate this one, dear, just apply the limit. What's wrong in that? Pi by 4. Done. That is equal to, what do you get here? 2. That's there. You have here theta tan inverse, or like integrating sec square theta is tan theta. Sec square theta is tan theta minus, you have here again, here it is, this thing will give me tan theta d theta, and then your limit 0 to pi by 4. Now one more step is there, dear. You need to just integrate this one, and integrating that one would give you what? This one is theta tan theta minus, this one is minus log. We have discussed so many times about this one, and then your theta to pi by 4. This is pretty important. Namala tan theta and integration of tan theta is nothing but minus log cos theta. Okay, keep it in your mind. This one I have already told you several times in the last exercise, dear. So if it is so, just applying these values, what? Okay, we will just write it there, dear. 2 into theta, namala tan theta. This will be plus log cos theta, then your 0 and pi by 4. Yes, that's it. Now just need to go ahead, and 2 is common here. Okay, better keep it. Okay, that's common for everything. Inside you're gonna apply pi by 4. So pi by 4 into tan pi by 4, all these values you need to know, plus again log cos pi by 4. Okay, so that's done. Upper limit minus, when you apply a 0 here, the complete term will be 0 because theta 0, complete term is 0. Then this one is log cos 0, dear. Yes, that's it. And then close the bracket. That's equal to 2 into, what is this one? Cos 0 is 1. What is log 1? Is 0. Okay, so that term is not there. Over here, pi by 4, tan 45, tan pi by 4, what is the value? 1. Plus you have log cos pi by 4 is cos 45, 1 by root 2. 1 by root 2. Okay, the values are that's equal to 2 pi by 4 plus, now mostly I have seen like in log and all, if you have a root, you take it up and then, okay, I will just show you. Can I write like this? 2 raised to minus 1 by 2, because root of 2 means 2 raised to 1 by 2, right? Then I just took it up in the numerator. So I got minus 1 by 2, which I am gonna bring it over this side, because as you know that what? A property log of a raised to b is what? B log a. Okay, power. So what I can write here? I can write 2 pi by 4. Yeah, this will come all the way down here, and minus 1 by 2 log 2. Right? With this property, dear. With this property I will get it. So what I will get after this? This is gonna be, okay, if I multiply the 2 inside, pi by 2, because that will get cancelled with 4, so it will get pi by 2, minus this 2 and 2 will get cancelled, so it will be log 2. That's it, man, that's it. This is gonna be my answer for what? For my third question. Okay, then move on to the fourth one then. On to fourth question. 0 to 2 x root x plus 2 dx. Already it is given that x plus 2 we need to take it as t square. So let's see. You don't need to think too much, because you need to get over here t square so that I can just remove the root. So okay, so if I'm taking it like this, t plus x plus 2 is equal to t square. When you differentiate, what are you gonna get? It's dx, because x in a dx, 2 is 0, that's equal to 2t dt. So at the place of dx, what do you need to write? 2t dt. Okay, so and then your limits, let's check on what is limit. When this is x, right? X is equal to 0. T and the okay, t is equal to 0 idumbo x in the, so it's gonna be t is gonna be root 2, because e root 2 alle idu square taadapumba root. When x is equal to 2, what happened to t? 2 number 4, then it's 2. Okay, so what happened to this limit? 0, it's root 2, and 2 over here, it's 2. Fine. Okay, yeah, it's 2. Then what happened here? If this one is t square, then what is the value of x? From here, what I can write, x is equal to t square minus 2. So what is x here? It's t square minus 2. Getting it right? Okay. Then root of this one is t square. T square dx is what? Dx is 2t dt. Just carefully write it. And then over here, root 2 to 2, t square minus 2. This would be root and square could be cancelled, and you will get a t, but with this t you will get a t square. This 2 could be written outside, which is a constant, and then dt. Any confusion? Confusion and just rearrange it. Okay, and then this t, and with this t it is t square. Fine. Then I'm gonna multiply inside. Yes, 2 root 2 gonna multiply inside, then I will be getting t raised to 4 minus 2t square, then your dt. Yes, now you're gonna integrate this. So if I start to integrate, what I will be getting here is t raised to 5 by 5 minus 2 t raised to plus 1, is it? And 3. And then I'm gonna apply the limit, which is gonna be root 2 and your 2 here. Yes. So let's see what I'm getting here. So 2 is a common. Then 2 inside will be 2 square by 5 minus this one would be 2 cube and 2 raised to 4. This is not, this is 5. Okay. Yeah. This is going to be 5, yes, and then by 3 minus your lower limit, which is root 2. But root 2, okay, I will just write it. In the next step, we will just expand, or whatever could be taken out, we will do that. 5 minus, this is going to be 2 into root 2 the whole cube by your 3. That's it, right? Yes, we applied the limit. So what I will be getting here? Let's check. So 2 is common. Then namala 2 square, 2 raised to 5, alle? 2 raised to 5 and 2 into 2 into 2. 2 into 2 is 4, 2 into 2 is 4, 4 into 4 is 16, 16 into 2 is 32, right? Okay. So is that one? Like 2 into 2 into 2 into 2 into 2. 2 into 2 is 4, 2 into 2 is 4, 4 into 4 is 16, 16 into 2 is 32. So you have 32 by 5 there, and minus, this is gonna be 16 by, you have 3, okay, and here minus, അടുത്ത സ്റ്റെപ്പിൽ നമുക്ക് എല്ലാം കൂടെ ഒരുമിച്ച് എഴുതാം കേട്ടോ. മൈനസ് ഇവിടെ ഒന്ന് ആലോചിച്ചേ, √2 into √2 into √2 into √2 and to √2. 2 √2 is 2, another 2 √2 is 2, that means 4. That will give you 4 √2. Just think over it, okay, by 5 minus, over here 2 വെളിയിൽ പോകും, അപ്പോൾ with this 2 it will be 4. So 4 √2 by √3. That's it. So what I'm gonna do here is I'm gonna expand this one, dear. Okay, expand or just simplify it, take the LCM, whatever you can, you do it, and at the end what you are getting is your answer, dear. Okay, നമുക്ക് നോക്കിക്കളാം എങ്ങനെ കിട്ടുന്നതെന്ന്. Okay, ഇപ്പോൾ I'm taking the LCM, then this is gonna be 15, right? 15, then into 3 will give you 6, then 96 minus, ഇതിൻ്റെ കൂടെ 16 കൂടെ ചെയ്യുമ്പോൾ 16 into 5 is gonna be like 30, then 180. It's gonna be 80 minus, this is gonna be again 15. 3 you need to multiply with this, that will give me 12 √2 minus 3 into 4. Then 5 into 4 is 20 √2. Okay, and with that 2, and here it will be, and the term 80, 90, 16 by 15 minus, idanda subtract cheyumbo minus 8, okay, minus 8 √2 by 15 അല്ലേ, ഇതിൻ്റെ ഇതും കൂടെ ചെയ്യുമ്പോൾ, അല്ലെങ്കിൽ √2 വെളിയിലെടുത്തോ, then 12 minus 20 is what, minus 8, dear, this one. And next step, you're gonna open this, so what you will get here is 16 minus 15 plus 8 √2 by 15, dear. And this is a common, actually, you can, in fact you can write it with, okay, now I'm gonna take a common outside, 8, so 2 into 8, I'll write it by, this is gonna be 2 plus, okay, 2 plus ഇവിടെ √2, because ഇവിടെ നിന്ന് ഒരു 8 വെളിയിൽ പോയി, so it's 2 plus here 8 went, so it's √2 by your common 15, right? Okay, that is equal to your 16, and then 2 plus √2 by 15. Yeah, and in your textbook I think this is given like this. They have already taken a 2 again. If someone like feels like, sir, this is not the answer, like I have got it in the previous experience, that's why. So I'm gonna take a √2 outside, okay, √2, idil √2 veliyil eduthu, appo I will be getting here √2 plus 1 by 15, dear. Yeah, this is what answer for my fourth question. Now just multiply inside, the √2 2, this one is √2, so this is what my answer for my fourth question, dear. Yeah, move on to the fifth one then. On to fifth question, 0 to pi by 2 sin x by 1 plus cos square x dx. അപ്പോൾ ഇവിടെ എന്ത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുമെന്നുള്ളതാണ് വളരെ ഇമ്പോർട്ടൻറ്റ്, അല്ലേ? നമുക്ക് ഏതെടുത്ത് കഴിഞ്ഞാൽ നമുക്ക് എന്ത് കിട്ടും? എന്തായാലും നമുക്ക് 1 plus cos square എടുക്കാൻ പറ്റുമോ? 1 plus cos square എടുത്തു കഴിഞ്ഞാൽ നമുക്ക് 2 cos square എന്ന് വെച്ച് കഴിഞ്ഞാൽ, ഞാൻ പറഞ്ഞത് ഡിഫറെൻറ്റ് സിനാരിയോസ് യു തിങ്ക് ഓഫ്, like if I take this one here and I put it as t, okay, and I will be getting like 2 cos x then sin x, and all those things are not there, no. Okay, so think systematically. I'm not telling you that jump over it, now this is what you need to put and just put it and get the answer, no. Think by yourself. നിങ്ങൾ തന്നെത്താനെ ഒന്ന് കുറച്ചൊന്ന് ആലോചിച്ച് നോക്ക്. ഞാൻ വെറുതെ പറഞ്ഞിട്ട് ഓക്കെ ഇത് ഇവിടെ ഇതിടണം എന്ന് പറഞ്ഞിട്ട്, like there is no purpose in that. You need to think by yourself. Okay, keeping like this, no, it doesn't work. Okay, now what happened if I put like cos x is equal to t? its differentiation is over there. Yeah, I cannot take 1 plus cos, because 1 plus it's gonna be always cos square. So you cannot take this. So cos x is equal to t. If I am taking, what happens then? Nothing. If I differentiate, what I will be getting? If I differentiate with respect to x, I will be getting minus sin x dx is equal to dt. Isn't it? Is there? Yes, it is there. It's okay. Now it's okay with the minus, no issues, because sin x dx is gonna be minus dt. That is the only difference what you will get. Substitute over here, no problem. Let's see. So this will be, limit will also change. Limit will also change. Yes. Now let's see. Now this is what we have taken. Cos x is equal to t. So when x is equal to, is it x? Yeah, x is equal to 0. When x is equal to pi by 2. What is the value of what? T. Yes. What is t will be what? Let's see. When x is equal to here 0, so cos 0 is 1. So t is equal to 1. When 90, cos 90 is 0. So where it is pi by 2, it is going to be 0. So what happens? So this becomes 0, it's 1. At the place of pi by 2, it's going to be 0. We cannot deny the fact there, because this is what we got. Okay, so whatever we are getting, you need to put it over here. And what else now? Okay, now substitute. Cos x sin x minus dt by 1 plus cos square is your t square. Okay, I got something here which is 1 to 0. Minus can't I write like 1 plus t square dt, dear? What is this one? This is nothing but your tan inverse t, isn't it? And you have a minus outside, and then your 1 to 0. That's it. Just apply it. So this is gonna be, this is your t minus out end, then your 0. So this is gonna be tan inverse 0 minus tan inverse 1. That is equal to minus, this is gonna be 0 because tan inverse 0. 0 minus 1 pi by 4, 45 minus pi by 4. This minus, when you multiply inside, it's gonna be pi by 4, dear. Yes, then this is what my answer for my 5th question. It's very easy, right? Only the logic is just think over a bit, dear, and then understand that, okay, now this should need to go over here, substitute, and then get it. Try, you will get it. Okay, so that's it. So moving on to the 6th question then. On to 6th question. Integral 0 to 2 dx by x plus 4 minus x square. This is our question. Now what should we need to do? You need to start factorizing the denominator here, and then a proper fraction. We have an x square here. Okay, now just try out with okay, making this a perfect square. Perfect square. Okay, here minus because x square now minus, so I'm gonna take minus outside. So what I will get here is x square, then this will be x minus x, this will be minus 4, right? Yes, and then I'm gonna make this one as a perfect square, dear. 0 to 2, then what you have here is dx by, if you want to, okay, now keep it here itself, because we are gonna make this one, and then we're gonna bring something out. Let's see what is out, coming out. What you need to do here, take that center or the middle term, dear, coefficient, the x, then take the half and then square it. So half is what? By 2. So that means it will be plus 1 by 2, half of 1, the whole square. You already have a minus 4 there. And when you added something, you also need to subtract with the same thing, which is 1 by 4, isn't it? Yes, done. Now, that would give me 0 to 2. This is in fact like dx, I'm gonna take it to a side, okay? 1 by, what I'm gonna get, okay, let this one be x square minus x. as of now, okay, plus 1 by 2 the whole square. Now this one is a square minus 2ab plus b square. That is why we are taking the half and adding and subtracting in order to make a perfect square. This is perfect square now. But this one you need to simplify, and that would give me 16 and is it 16? Yeah, 16 and this one is 17. So minus 17 by 4. Okay. This one I'm gonna take it out. 0 to 2. So already there is a minus. So when I'm gonna take it out, it's gonna be positive 17 by 4. Because if I'm gonna bring it in, already there is a negative sign. That's why this negative and this one will be positive if I'm taking it out. Okay, so minus, this will be x square. Okay, now I'll just write it, and now the next step I'll just make it square dx, and here it's dx. That would give me how to make this one dear a perfect square. In order to make that, it's gonna be 17 by 2 the whole square. But this is 1 by a square minus x square formula. Okay? Minus, this is gonna be x minus 1 by 2 the whole square. Isn't it? Yes dear, in that form. Now how to integrate this? You have a formula. What is the formula? Okay, we'll just write that formula dear. Yes. Now what is the formula here? What do you have? You have here 1 by a square minus x square. If such a thing is there, when you integrate, you have a formula which is 1 by 2a log. Okay, all these formulas I have told you several times. Just keep it in your mind. All these things are so important. Fine dear? Yes. So this is what I have. But what the main problem here is, when you have such a thing, what you need to do before that is, you can go ahead and you can substitute things dear. What you're gonna substitute over here is, let this one, I'm gonna take it as x minus 1 by 2. Okay, I'm gonna take it as t, because this is substitution what we are doing, right? So I'm gonna take this whole thing as, because as you know that this is coming in this straight in this formula dear. If not, if you don't want to put a substitution over here, you can do it with the formula. But I do believe that no, in this exercise obviously you need to substitute it. That's what I'm doing it. If else, like if for the board exams and all, if you are getting it, you can just go ahead and do it. But over here I'm just gonna substitute with a t, this one, because the differentiation and the mail upon the dx and okay, when you differentiate it, it's gonna give me what? Dx is equal to dt. Dx, yeah, is equal to dti. But e full term on the ti. Now I'm gonna change the limit also then. So what is it when it's gonna be x, right? Okay, when x is equal to 0, what is the value of t? When x is equal to 2, what is the value of t? That is what we need to check. Yeah. So 0, what will be? So over here, now if it is 0 here, your t will be 1 by 2. If it is 2 here, then this will be 4 minus 1, 3 by 2. So what will happen to this? This will be now 0 to 2 will change to 0 will be minus 1 by 2. Getting it? Now this 2 will be 3 by 2. This would be 1 by root 17 by 2 the whole square minus t square, and your dx is what? Dx is your dt. So dt. Done. Now your formula supplied. So when I integrate, what I'm gonna get? 1 by, so already there is anything. Okay, 1 by 2 into a is what? This, which is root 17 by 2. Then you have log, then modulus a is again root 17 by 2 plus x is what? You have t here, by same thing root 17 by 2 minus t, and you have integrated it here. So you need to apply the limit. Okay, this is a constant, so I can just put the limits over here, minus 2 and 3 by 2. Fine. Yes. So this and this could be cancelled. What you get here is 1 by root 17. Yeah. Then you can need to multiply, or you just need to apply the limit, and when you apply it, it's gonna be log. This is gonna be root 17 by 2 plus t is 3 by 2. Then by root 17 by 2 minus 3 by 2. Yeah. What's the problem? Minus your lower limit, which is gonna be root 17 by 2 minus 1 by 2 by root 17 by 2 plus 1 by 2, because minus and minus plus. Okay, that's it dear. Now again one more step, and after that we'll do it there. Now what happens here? Okay, now let me just simplify it a little bit, then we will just go ahead and simplify it more. Okay, this is all about simplification now. This is gonna give me 3 plus okay, root 17 plus 3 by 2 by this one is root 17 minus 3 by 2. In fact, this 2 will get cancelled. Okay, 2 cancel out, minus log. You have the same thing over here dear, which is root 17 by 2, which is in fact like you can take it together, right? Minus 1 by root 17 plus 1 by 2. This 2 and this 2 would be cancelled. So what you will get after that? Yeah, let's check. So this one would be 1 by root 17, then log, this is gonna be root 17 plus 3 by root 17 minus 3 minus log, here log root 17 minus 1 and root 17 plus 1 dear. Be very careful. That is the only thing what you need to see in these type of question. If any one step you miss out something, it's gonna be wrong. So this is gonna be like, this is the entire 1 by root 17 is a common for these. Okay. Now this is log a minus log b. What is log a minus log b? Log a by b. So what I can write, log, okay, I will just write it in full, 17 plus 3 by this thing, which is 17 minus 3 by this thing, which is root 17 minus 1 by root 17 plus 1, right? Yes, which in fact I can write it as 1 by root 17 log, I'm just gonna multiply it, which is root 17 plus 3 by root 17 minus 3 into, you need to reciprocal it, which is 17 plus 1 by root 17 minus 1. Okay dear? Yes. Now what? Just go ahead and multiply it, which is gonna be 1 by root 17 log, this 17 because it's a whole square, root poem. Then you have 3 root 17 and 1 root 17, that will be plus 4 root 17, 3 root 17 and 1 root 17, 4 root 17, plus what do you have here? This is 3 by, this is again 17, and then you have here again minus 4 root 17, this is gonna give me plus 3, that's equal to 1 by root 17 log. From here you can get 20 plus 4 root 17 by 20 minus 4 root 17. And from here what you can take it outside and you can cancel it and you can get something there, that is 1 by root 17 log. What you will get here? 4 4 4 by 4 താഴെയും 4 വെളിയിൽ എടുക്കാം കേട്ടോ. That is 5 plus root 17 yeah by 5 minus root 17. Yeah, it's a hell lot of a calculation, man. So that is how you do it, these type of problems, which will be little lengthier, but you will get it, man. Okay, so that is equal to, so this would be cancelled. Thus this one you need to take the conjugate, 1 by root 17 log, you need to take the conjugate and multiply it over here. So that will give you 5 plus root 17. You are gonna take the conjugate of the denominator. Okay, appo idena conjugate ennu vechal idinte plus root 17. Okay, this one by idinte endha 1 minus 17. ഇതൊക്കെ ഒരു സ്റ്റെപ്പിൽ എഴുതാന്നല്ലേ ഉള്ളൂ, പക്ഷേ like I just want to show you, that's it. This now what, 1 by root 17 log, this one is gonna be 25, denominator എന്ത് കിട്ടും 25, because 5 square, a minus b into a plus b, a square minus b square, so 5 square which is 25 minus 17 square, root 17 square, that is gonna be 17. Yes, and this one is gonna be wholes, like a plus b the whole square here, or just multiply it inside, you will be getting 25. Yeah, and then this with 15, this with root 17, and this with root 17 will give you 10 root 17. Yeah, 2 into, yeah, that would be the one, and plus you got to see like this one square which is 17. Okay, try by yourself dear, try by yourself. 1 by root 17 log, then this would give me 17 and 25. So okay, the rest what is left now I will do it over here. Okay, calculation. Now 25 and 17, 25 and 17 is gonna be 7, 12, 1, and it's gonna be 42. Yes, so 42 plus what is it, 10 root 17 by, what do you have here, this one is 8. Yeah, 8, and is it 8, 17 plus yeah, 8 is 25. Yeah, then could we cancel anything? 1 by root 17 log, you can take 4 outside, not 4 dear, 2 outside. Yeah, 2 and this 8 will get cancelled. So what do you get here is, when you go ahead with 2 outside and cancelling with this 8, so 2 outside, it will be it is gonna be like 21. Yeah, plus 5 root 17, then dividing it 2 by this one will give you 4. Yeah dear, and just I will finish off the problem here. Okay, so already you got through all these steps. This is where the main crux of this question is. So basically you need to just sit and do it thoroughly and just see all the steps, and then so what else I will get here? I think like, yeah, this is gonna be the answer. What is the answer? 1 by root 17, your log. Yeah, inside the log what you have here is 21 plus 5 root 17 by, because I don't have anything else to take it out. Yeah, this is gonna be the answer, man. That's it. Yeah, that's it. Okay, moving on to the 7th question then. On to 7th question dear. Integral minus 1 to 1 dx by x square plus 2x plus 5 ആണ് നമ്മളെ ഈ question. താഴെ വന്നിട്ട് perfect square. Yeah, try it. It's not, but you need to make it minus 1 to 1. എങ്ങനെ ചെയ്യുക? 1 plus x square, നമ്മൾ x ൻ്റെ കോയിഫിഷ്യൻ്റ് സ്ക്വയർ ഹാഫ് എന്ന് വെച്ചാൽ എന്താ, ഇപ്പോൾ 2x തന്നെ വരും, അതിൻ്റെ ഹാഫ് 1 സ്ക്വയർ. യാ, അപ്പോൾ ഇതൊന്ന് നോക്കിയേ, this will be a square plus 2ab plus b square. അപ്പോൾ ഞാനിപ്പോൾ ഇവിടെ ഒരു 1 ആഡ് ചെയ്ത് കഴിഞ്ഞാൽ I already have a 5 here. You need to subtract 1 because ഇവിടെ ഒന്ന് 1 ആഡ് ചെയ്തു. Now I need to subtract 1. Yes, and then your dx, right? And which in fact give me this one is I already have told you, like it's like a square plus 2ab plus b square. So this is gonna be x square plus 1 the whole square. Yeah, then this would be 4 dx. So in fact, I can go ahead and write it like this. What is it? 1 by, this is x plus 1 the whole square plus 2 square dx. Are you getting some idea what we can do with this? What is it? Let x plus 1, I'm gonna take it as t. Okay, so if you differentiate with respect to x, what you will get here, it is dx is equal to dt. Then differentiate. Then if it is so, dear, what are the limits then? What happens to the limit when x is equal to minus 1? Minus t and the minus 1 in this one. If I put the minus 1 over here, minus 1 plus 1 is going to be 0. So this is 0. And in this case, when x is equal to 1, your upper limit, then what is going to be the value of t is 2. Just see here, 1 plus 1, 2. So if in this case, what will be my new substituted one with the limit? This is going to be minus 1 divided by 0, 1 divided by 2. Fine. And then you have this one, 1 by, you have t. So t square plus already 2 square dx in a dt. So you are dt here. So everything in terms of t. Now just simply go ahead and integrate. But as you know, that what is this one there? This one looks like something which we know. 1 by x square plus a square. And the formula 1 by a tan inverse x by a, right there. Okay, so in that case, what you will get? So when you integrate this one is gonna be 1 by a and the 2 so 1 by 2 here tan inverse, this is x in the t by 2. That is constant, keep it out, then 0 and 2 dear. So now just apply the limit dear. What are you gonna get? 1 by 2 is here, then you have here tan inverse t ki param 2 by 2 minus your lower limit, which is tan inverse 0 dear. That's equal to, it's pretty easy, right? 1 by 2 into, this is gonna be 1, so tan inverse 1, yeah, and then this is 0. What is tan inverse 1? 1 pi by 4. So just pi by 4. So that will give you pi by 8. And this is going to be my answer for my 7th question. Fine. On to the next one then. On to 8th question dear. Integral 1 to 2 1 by x minus 1 by 2x square e raised to 2x dx. Now the integral e raised to x f of x plus f dash of x. You still remember that? What are you gonna get when you integrate it? E raised to x itself and then your first function, isn't it? Isn't it? So if it is so, can we just think of them the same way like what is written over here, which is e raised to x, but over here it is 2x dear. So what I will do is 2x in a variable or a single variable at t. Okay, let's see if I do so, what will happen. So if you differentiate, this will give me dx is equal to dt. dx dt at t. Okay. ഇനി ഇപ്പോൾ നമുക്ക് അത് മാത്രം പോരല്ലോ, നമുക്കിവിടെ ലിമിറ്റ് എഴുതണ്ടേ അല്ലേ? ലിമിറ്റ് എഴുതാനായിട്ട് നമ്മൾ എന്താ ചെയ്യേണ്ടേ? Like when x is equal to, now is there anything else? Now I'm gonna take that's it here. And let's see what we are what you are gonna get. Okay, x is equal to what? 2. ആ രണ്ട് സമയത്തും t ന്റെ വാല്യൂസ് എത്രയാണ്? 1 ആവുമ്പോൾ it's gonna be 2. Yeah, putting it all the way down here, 2, then 2 ആവുമ്പോൾ is gonna be 4. ഈ രണ്ട് കിട്ടി. അപ്പം 1 ആയിരിക്കുമ്പോൾ 2 and here it's 4. Fine, that's done. Now what we have here? Okay, now all these things we just need to change. എന്തൊക്കെയാ ചേഞ്ച് ചെയ്യേണ്ടേ? ഇപ്പോൾ ഇതിനെ നമുക്ക് in terms of x what I can write? X over here is t by 2 അല്ലേ? Okay, x is equal to t by 2. So what I can write here is 1 by t by 2, yeah, minus 1 by, ഇതിനെ നമുക്ക് എന്തെഴുതാന്ന് വെച്ചാൽ 2 into x എന്ന് വെച്ച് കഴിഞ്ഞാൽ the whole square, right? Okay, but still it's gonna be the same thing, like എന്താണ് ഇവിടെ t square by 4 എന്ന് പറഞ്ഞുകൊണ്ട് വരും, ഇത് രണ്ടും ക്യാൻസൽ ആവും. Then e raised to, this is gonna be t, dx is what, dear dt. Very carefully write it, dear, okay? It's very easy, but if you make any mistake, the whole thing will go, as I said before. This one we can reciprocal എടുത്തിട്ട് നമുക്ക് എഴുതാൻ വേണ്ടി പറ്റും. Reciprocal എടുത്തിട്ട് എഴുതി കഴിഞ്ഞാൽ ഇങ്ങനെ കിട്ടി, 2 by t എന്ന് കിട്ടി. Over here this get cancel, and what you get here is minus 2 by t square എന്ന് കിട്ടി. Now is it like, okay, now this is gonna be like 2x is 2xd 2xt 2x നെ നമ്മൾ ചെയ്യാൻ എടുത്തേ. So what is the differentiation here? It is 2 dx. If it is 2 dx, then what is dt? Dx is equal to dt by 2. Sorry, I just missed out something over here, which you need to put it over here. That is why I was just checking, like again and again, what happened here. Okay, it is not just dx here, it is 2 dx, because 2 illa evade constant into x in the differentiation is dx. Yes, so we have this. Appo idu ezhuthi ini ivada by 2 undale. Yes, and then after cancelling all these dt, ഞാൻ ഈ 2 നെ ഞാൻ വെളിയിൽ എടുത്തു, അല്ലെങ്കിൽ okay, as if now I'm just writing it over here. Fine. The next step, what I'm gonna do is, okay, here also there is a 2, so I'm gonna take it out as common. താഴെ ഉണ്ട്, അത് താഴെയും വെളിയിൽ എടുക്കാം. Okay, I can cancel it. 2 and 4, what I'll get here is 1 by t minus 1 by t square. Yeah, this is what I was talking about, et dt, dear. This get cancelled. Now check very carefully, ഇതിൻ്റെ differentiation അല്ലേ ഇവിടെ കിടക്കുന്നത്. 1 by t in the differentiation is what, 1 minus 1 by t square. The differentiation is there, just like what I said here. So what is my answer here when you integrate? It's gonna be, now if you want to get the proper way in what I have written there, this will look like this. Et ഇവിടെ എഴുതി ഫ്രണ്ടിൽ into 1 by t minus 1 by t square. Just compare it now, okay, and you will start to write, or you will integrate and write, this is my answer here. You don't need to think twice. This into this will be the answer if you go and integrate this. So what I can write straightforward, what I will be writing here is e raised to t edidi, e raised to t edidi, then into your 1 by t. Okay, അതാണ് നമുക്ക് ഇൻറ്റഗ്രേറ്റ് ചെയ്ത് കിട്ടുന്നത്. Then your limits 2 and 4. So with that, what I will be getting here is, നമുക്ക് ഇങ്ങനെയല്ലേ കിട്ടുന്നത്, et by t ഇങ്ങനെയാണ് നമുക്ക് കിട്ടുന്നത്. ഒന്ന് നോക്കി കഴിഞ്ഞാൽ അല്ലേ, ഇനി ഒന്ന് ലിമിറ്റ് അപ്ലൈ ചെയ്ത് നോക്കിയാൽ എന്ത് കിട്ടുമെന്ന്. e raised to ഇവിടെ 4 വരുമ്പോൾ 4 by 4 minus e raised to here it is 2 by 2. അപ്പോൾ ഇവിടെ നമുക്ക് കുറച്ച് കോമൺ ആയിട്ടൊക്കെ എടുത്തു കഴിഞ്ഞാൽ e സ്ക്വയർ വേണമെങ്കിൽ വെളിയിലെടുക്കാം, by ഇവിടെ 2 വേണമെങ്കിൽ വെളിയിലെടുക്കാം. what I will end up here is e raised to e square by 2 minus 1. Yeah, minus 1. If you want to write, you can get it. Or ഇപ്പം എങ്ങനെ വേണോ നമുക്ക്, this would be the answer. Or else if you want to just take it this one, yeah, take this one, and then if you want to just make a common out of it, which is 4, yeah, and then if you want to write it like this, e raised to 4 ഇത് 2 ഇങ്ങോട്ട് പോകും, minus 2 e raised to 4, yeah. എനിക്ക് വേണമെങ്കിൽ എനിക്കിവിടെ e raised to 4 അല്ല, e raised to 2, sorry, e raised to 2. Then if I want to take that e raised to 2 outside, I can write it. So it's all these answers are gonna be same, dear, or it's gonna be correct. Okay, now this could be written as an answer, this would be an answer, and even this one, if you write it, it's gonna be an answer, dear. Fine, in which way you want it, you can write it. So that is what our answer for our 8th question, dear. Move on to the 9th one then. On to 9th question. the value of the integral, this one here, is gonna be these 4 options. Okay, so it's a multiple choice question, and this is your integral 1 by 3 to 1 x minus x cube the whole raised to 1 by 3 by x raised to 4 dx. This is one of the easiest question, but most of the students gets complicated with it, or just gets fully pissed off with at the end now what to do and all, like just leave this question and go. But it is very easy, dear, if you think a bit. Okay, now what I have here is, now when you look at the question, dear, you can see that this is gonna be 1 by 3. If anything whole raised to cube or something, or square or any such thing, you can expand it. But what happens to the 1 by 3? I cannot do anything. So what I'm gonna do here is, I'm gonna take a cube from here as a common. Okay, deliberately I'm just taking a common. Now ഇവിടെ നിന്ന് നമ്മൾ ഒരു common എടുക്കുകയാണ്. എന്താ common എടുക്കുക? X cube I'm gonna take it out. So when I'm taking it out, I'm gonna get here 1 by x square. Okay, അല്ലേ? X cube വെളിയിൽ പോകുമ്പോൾ 1 by x square. ഇത് അകത്തോട്ട് മൾട്ടിപ്ലൈ ചെയ്ത് കഴിഞ്ഞാൽ ക്യാൻസൽ ചെയ്തിട്ട് x തന്നെ കിട്ടും. Minus this one is gonna be 1. Yes. So in the bracket, what is it? 1 by x square minus 1. Yes. And your 1 by 3. But if you just write this denominator with x by 4 and dx dr, this is wrong. Why? When you take x cube, which was already there inside 1 by 3, so I also need to put here what? Again 1 by 3. Fine. Getting what is it, dear? What the major mistake what students used to do? When I tell like to take it out, they take it out, not that 1 by 3. Fine. If I write it properly, this looks like this: 1 by 3 to 1 x raised to, that means x cube 1 by 3. So in after the next step, you can cancel it. Okay, then you have 1 by x square minus 1 raised to 1 by 3 and x raised to 4 dx. Yeah, now as I have told you, cancel these two. What do you get here? 1 by 3 to 1, you have x, that will also get cancelled with what? With your x raised to 4, right? So this x and 4 will go, you will get 3. So what you will get here? You will get here integral 1 by 3, then to 1, then you have here x, x square, not here, dear, not here, x square, which is 1 by x square minus 1 whole raised to 1 by 3 by, you have x cube dx. Think over here, dear, which if I take this bracket as t, okay, if I take that bracket as t, what happens? If 1 by x square minus 1, if I am putting it as t, when you differentiate it, what you will be getting? Okay, the differentiate is minus 2 by x cube dx by dt. I hope differentiation is okay for you guys. Okay, ഇത് മേളിൽ പോകും minus 2 minus x raised to minus 2, അതിനെ പിന്നെ ചെയ്യുമ്പോൾ minus 2 by x cube എന്ന് പറഞ്ഞിട്ട് കിട്ടും. Now check it, like 1 by x cube ഇവിടെ ഇല്ലേ, x cube താഴെ, എന്നിട്ട് dx മേളിൽ ഉണ്ടല്ലോ. So I can put the value over there, man. But I don't have this minus 2. So what I will do, I will make it like this: 1 by x cube dx is equal to, I'm gonna bring it down, so minus dt by 2. Yes, now I can put it this 1 by x cube dx in a I can put it this one, dear. Fine. So that's the logic. Okay, now again one more thing is there. When x is equal to what? 1 by 3 about t and the value, when you go for substitution, you need to know this, right? When x is equal to what? The next one 1, t is equal to what? Here this one, dear. X is equal to, so 1 by x square is what? 1 by 9, right? Minus 1. So so reciprocal, 9 minus 1, 8. So this will be 8. If it is x is equal to 1, you substitute over, dear. 1 by 1 is 1. 1 minus 1 is 0. You got the new limits. Okay. Now this one changes to what? 1 by 3, it is 8. Then if it is 1, then it is 0. Okay. Then what else happens, dear? This one, this whole thing inside the bracket is t. So t raised to 1 by 3, e 1 by 3, by, no, nothing. Okay, and this one, dear, which is minus dt by 2. Namma dx in a param. Alle, dx in a param dt. Fine, everything is done, perfect. Okay, dear, go ahead and integrate, that's it. So that's gonna be, okay, now take it out then. 8 to 0, t raised to 1 by 3 dt, that is equal to minus 1 by 2. You're gonna use, okay, you're gonna integrate this, so it will be plus 1 and 8 to 0. That's it, dear. That's equal to minus 1 by 2. This is gonna be 8, this is 3 plus 4 by 3, yeah, 4 by 3, by, this is gonna be again 4 by 3, right? Okay, and I didn't apply anything, 8 to 0. So when you apply the limit, dear, the first one 0, so that is 0, minus the second one you apply, it is gonna be 8 4 by 3 by 4 by 3. Okay, that I will do it. Now what I can do here is, okay, I will do it over here on the side, dear. Now how to get this one simplified very fast? 1 by 2 under, yeah, this one again, like you need to multiply with a negative 8 by 8. Can I write it like 2 cube? Yeah, 2 cube at 8, 2 cube, and then you have what? 4 by 3, right? 2 cube 4 by 3 by 4 by 3. So this cube and this cube could be cancelled, and 1 minus 1 by 2 into, you have 2 raised to 4 by, this could be taken up, that will be 3 by 4. So what all could be, or what all can be cancelled, man? This would be simply, endokka cancel cheyam? Ivida 4 undu alle, ivida 3 time undu, ivida 4 time undu. But idu ellam poi, idum poi, you get only 1 2, which is negative 2 in fact. Okay, negative 2. So negative 2, this one 2 is 2 into 3, that is gonna be 6. Yes, 6 is gonna be the answer for this question, dear. Okay, I hope you are getting it from here. Okay, so once I have this one, dear, what I did is I just simply applied my what? Applied the 8 here, that's it. Because 0, you're gonna get a 0. 8 applies to the 8 കിട്ടി. 8 ന് പകരം ഞാൻ എന്താ 2 raised to 3 എന്നിട്ടു. 2 raised to 3 എന്നിട്ടു. എന്നിട്ട് അതിൻ്റെ whole raised to ഇവിടെ already there is 4 by 3, which I can cancel with, and you will get what? 4 there. So മേളിൽ 4, താഴെ 4 എന്ന് വെച്ചാൽ 2 square. Then again a 2 here, so it is 2 cube. മേളിൽ cancel ആയി, so it's 6. It's pretty easy, like it's a small kid will do all these ones who is in 7th or 8th. Fine, that's it. About the cancellation, it was easy, and about the logic part, you just need to understand, dear, and that is something which you need to just follow it, and then only you will get the answer. Otherwise you will be totally pissed off with. Fine, on to 10th question. If f of x is equal to 0 to x t sin t dt, then f dash of x is, these are the options. That means this is given, what is it? F of x is said to be what? Integrating your this function on 0 to x t sin t dt. അപ്പോൾ നമുക്ക് ഇത് ഇൻ്റഗ്രേറ്റ് ചെയ്ത് എന്താണോ കിട്ടുന്നത്, what you are getting after integrating this, that will be what? F dash, f of x. First you need to find what? F of x. Why? Because you need to find f dash of x then. So you need to, after integrating it, you need to differentiate it and get the answer from these. Okay, so these are the options, dear. Let's see which one is true. Okay, so this is a function, so we will start to integrate it. Integrate what? First and second term, dear. Which one will be? Isolate this one, algebraic, so it will be the first term. So what is the what I have told you? What is the formula, dear? First function into integration of the second function, yeah, minus integration of differentiation of the first function. You need to differentiate the first function, which is with respect to 2 means it is 1, right, into integration of the second, then dt, and then this integral dt dear. That's it. Now when you get it or get on to the next step, when you go this one, after integrating you will be getting minus cos t, yeah, minus this one, okay, integration sign, let it be there. This one again will give you cos t, then again your dt. Fine, that is equal to this one minus t cos t, this one would give you plus, you need to integrate cos t dt. Fine, then after that, that's equal to minus t cos t plus, when you integrate cos t you're gonna get sin t. But what is missing over here is our limit, which is 0 to x, 0 to x, and here 0 to x. Fine, why not here? Yes, of course, 0 to x, yes, done dear. So done with that, now you need to apply the limit x. When you apply it, so minus x cos x plus sin x. Okay, now what happened to 0? Here whole thing will be 0. This is the first upper limit, minus this one already t in a 0 dukumba, it will be 0 dear, the whole term, plus already, then sin 0 is what? Again 0. So this is the only one what we have. What is it? Minus x cos x plus sin x. So what is this one? This is f of x. This is your f of x dear. And what is asked to find? You have asked to find f dash of x dear. So f dash of x, namakku idina differentiate cheyanam. How? Go ahead and differentiate, man. What is it? Idu verade ezhunnunnallo ta, ingane oru step onnu avashyamilla. X cos x plus sin x. Egane nammal differentiate cheya? This one, product rule. This one separately we can do it. That is equal to minus, okay, let it be minus a common dear. This one, first term into the second term, differentiation of cos x is minus sin x. Differentiation, yes, plus cos x into x into the 1 minus, already I have told you, I have taken it common from this product, okay, that's it. And then you have a plus sign, with your sign is going to be cos x. Now sin x into differentiate cos x, that's equal to idinagathotte jan multiply cheythu ezhudumba endu kittum. This is gonna be like, okay, one step over, minus x sin x, yeah, plus cos x plus cos x, yeah, that's equal to idinagathotte cheyumbo plus sin x minus cos x plus cos x. What should you need to do? Just simply cancel, man. And what's the answer? X sin x. X sin x. Yeah, it's there. So B is gonna be my answer for my last question. This is the 10th question here. Yes. So it's pretty easy, right? So this was our exercise 7.10. I hope you got a clear picture of how to do substitution in definite integrals. Substitution only you just need to know, dear. Rest you already know how to integrate it, or how to integrate definite integrals. So that was not too hard. Only the part is that you just need to understand where or which part should need to take and substitute. That's it. And then of course changing the limit. So I hope like you got a clear picture about how the substitution is done. And this video, I don't think like it's too hard or any hard questions were there in this exercise. It was pretty easy, it's pretty straightforward. So if any doubt is there, dear, do comment down below, and I would be very much there to help you out. Don't worry about it. And as well as I have given all my links, everything, so you can connect it to me at any point of time. Yeah, so that's it. So see you on next section. Arun here.